Thank you. So I was listening to this panel discussion yesterday on autonomous cars. And I was thinking to myself, there goes half my presentation for today. And then later in the day yesterday, there was another panel on IoT platforms. And that was the other half of the presentation. So today, what I would look to do is try to entertain you with some stories. And one such story that I would like to tell you is about the Indian Rebellion of 1857. And there's a subplot there about how this revolution gained momentum and how it grew into a major crisis for the British regime. So up until then, there had been other revolutions, mutinies, protests, but to a smaller scale. They were disjointed, not coordinated, didn't capitalize on each other's momentum. They didn't have an ecosystem that came together. So that's a word, ecosystem, that you'll hear often through my presentation today. Tensions, however, were rising throughout the country. And the final spark to this powder keg of a situation came in the form of events which sort of unfolded something like this. The soldiers of the East India Company, or sepoys as they were called, of Hindu and Muslim origin, were given these Enfield P-53 rifles, part of the standard ammunition that they got. And these rifles operated with paper cartridges, which came pre-greased from the factory. And the idea was the soldiers had to bite off the cartridge to release the gunpowder and then slide it into the gun, right? Now, the rumor was that the grease for these cartridges was made from cow and pig meat. Given the Hindu and Muslim soldiers, this obviously ran against their very religious fabric, and that sparked off the mutiny. Now, if it had been any other time, the mutiny may have risen and fallen like many in the past. What was different this time, ironically, was that it was the East India Company that had laid out the railroad network, which started to connect, parts of northern and central parts of India. And this allowed the mutiny leaders to congregate, to mobilize, to give this revolution the lift that it needed. So among many other things that contributed to this revolution, you could say that the fabric that this made this possible, the network that made this possible, was the railroad network. Okay? Now fast forward 150 years to 2012, and look at the role that social networks played in the Arab Spring and the revolutions in Egypt and Tunisia. Now, while on the topic of revolutions, we believe, I think we all believe, that we are at the doorstep of yet another revolution which is going to transform our lives in a major way. So let's take a peek at what that might look like. Since the invention of telephone in 1776, it took us 100 years to connect the first 1 billion places. It took us 25 years to connect the first 5 billion people. And we project that it will have taken us only 15 years to have connected the first 25 billion devices. So as you can see, the pace of this change is phenomenal. Now, we all know the benefits of having 5 billion of us connected. We are living in that economy right now, and we know how it's transforming our businesses, our lives, our industries. So imagine what things will be like when everything that benefits from being connected is connected. Robert Metcalfe, there was a reference to that earlier today. He's the founder of Ethernet, and he had postulated back in sometime in the 80s that the value of a network is directly proportional to the square of the number of connected things. So just imagine the possibilities there. Now, among the many trends that are transforming our industry and our lives is this phenomenon called IoT. Now, numerous studies have attempted to capture the value associated with IoT, some in number of connections, some in amount of investment dollars that are going to the space, some in the value to economy that this is going to generate, and you'll see figures nothing less than trillions in this space. And I think us large corporates also try to play up some of these things. But regardless of how you slice it and dice it, the sheer magnitude of this is sort of undeniable, right? And McKinsey released a study, I think it was last year, which said that the hype around IoT is phenomenal, it's huge, but the reality might actually be greater. So as you can imagine, IoT is an enabler for a wide variety of use cases. And each of these use cases have specific requirements that must be met in order for these use cases to be viable. Today, we should try to take a look at some of them. And the two ends of the spectrum here, so I've sort of broken this down into one, which we call massive IoT. It's all about volumes of connections. And there, think of use cases that will roll out in large volumes, possibly embedded with no access to on-grid power. Let me give you an example. Think of smart sensors deployed in an agricultural field. Sensors which are reading moisture and temperature, perhaps, and reporting it back to some central place. Large volumes distributed across. Think of sensors deployed in a fleet of trucks for monitoring and tracking purposes. Now, given this use case, some of the requirements, key requirements that you will see here, one is cost. Why? I'm talking about billions of sensors, so they better be affordable. Second, battery life. Why? Again, given the nature of these installments, they need to operate on a fit and forget basis. There's no way I'm going to go down to the field after installation trying to replace batteries on these, given the volumes and the location. And three, the range of communication. Again, look at installments like basements of buildings, where some of these smart meters are going to be installed. They need to be able to connect to the network, so coverage is also a requirement. At the other end of the spectrum, we call it critical IoT, also called tactile internet. Here, the use cases are mission critical, zero margin for error. It's all about trust, integrity, security of the system. Think of examples like remote surgery. Think of automated braking for your car. There's zero margin for error. You need to have a network that is reliable, highly available, fault tolerant, with very, very low latency. Predictable. Those are some of the things that you look at. So having looked at, and of course, these are the two ends of the spectrum. There are many things that lie in between as far as use cases. So what needs to happen in order to support these use cases? So I'm calling it Keys to Accelerate Iot. So by no means is this list exhaustive, because when you talk about IoT, you look at things like IPv6, you look at need for common set of standards, you look at regulation and support that needs to come in. There is privacy and security concerns that must be addressed. All of that, network infrastructure, all of that is there. The focus today will be on what needs to happen at the device end, as well as the network access end, from a cellular perspective. Somewhat of a narrow focus. We have only 20 minutes after all, right? So 3GPP, sorry, this slide is the only one, I promise, has some sort of technical jargon here. 3GPP, or Third Generation Partnership Project, it's a standards body which lays down specifications for wireless networks. So some of the technologies that we use today, 2G, 3G, 4G/LTE, all of those are based on 3GPP. Right? So for massive number of connections, there are extensions to current technologies. There's narrowband IoT, there's LTE machine type communication, there is something called extended coverage for GSM, which is a suite of technologies to be deployed based on use case, spectrum availability, choice of country, deployment scenario, and so on. For low cost, two sub-segments here. One is the devices themselves. When we talk about billions of sensors, the device industry is squarely focused on driving some of these costs down. There are companies like ARM, Intel. They're actively working on how to make these sensors and the circuitry that needs to go in them affordable. Then there are these IoT gateways that these sensors will connect to, and the IoT gateway will then connect to the network. And for IoT gateways, if you look at the cost of a 2G module today, it's between $4 to $10. And it's affordable. It's viable for some deployment scenarios for IoT as a gateway. These are not going to be necessarily the ones that are in billions. But the cost of an LTE module today is about $40. Not okay for high volume, low margin business. And 3GPP and companies that are part of that consortium are actively working on pushing those costs down. For long battery life, here we're talking about battery life that needs to last in the order of years. 10 years battery life is what we're talking about. So beyond hardware simplifications that need to happen on these devices to reduce battery consumption, There are other software algorithms that must be developed. There's something called deep sleep mode, where a device can go to sleep for days, even weeks at a time, and then wakes up, reports on a certain data, and goes back to sleep. For coverage, I mentioned extended coverage, GSM, which is about repeating signals at periodic intervals and reconstructing the signal at the other end to be able to reach deep places like basements of buildings. I will talk about high reliability and low latency in a minute. Excuse me. So the technologies that I've talked about so far are based on extensions of existing technologies which are already available, like 2G, 3G, LTE, and so on. But if you ask somebody who's in telecom space, or even otherwise, what is the future of telecom? Most people will tell you, 5G. We'll find mention somewhere there. And it is true that by 2020, operators will have started deploying 5G in their networks. And it's also true that 5G takes several strides towards enabling IoT. But the future needs to start today. Operators need to make their positions in the network clear today based on current networks and current technologies, so that when 5G comes around, they're best positioned to be able to leverage the fuller potential of IoT that gets enabled by 5G. Now, perhaps one of the most interesting aspects of 5G, among many others, by the way, 4G to 5G is not incremental like it was from 3G to 4G. One of the most interesting aspects of 5G, perhaps, is the fact that it is multi-purpose, and it allows support for different virtual networks with different network characteristics using the concept of network slicing. So think of a smart meter again, and using 5G constructs, it talks to the network and it says, I want a slice of the network which is reliable, as in I should get an acknowledgement back. But I don't care about latency, I don't care about bandwidth, because I'm sending a very small amount of data. So low bandwidth, high reliability, that's the characteristic I want. I acquire this network slice, I do my business, I release the network slice. Think of a connected car. I require two network slices. One for streaming media, so I ask for a high bandwidth for streaming media. And another one for real-time traffic updates or automated braking. So there I want very low latency. So I get these two network slices, acquire them, use them, release it back. And this concept of being able to use a common network infrastructure, not have to purpose-build network infrastructure for each industry vertical, that is going to open up a wide variety of use cases. Having looked at, a high-level look at, what some of the use cases are and some of the technical advancements that we are all working on, those in telecom anyway, it's reasonable to ask, what is the potential for IoT? How do we expect IoT to, touch our lives? In what ways? Right? So before we go there, I want to take a quick, show of hands from you. How many folks do we have here, let's say, from the automotive industry? Can I have a show of hands, please? Okay. From healthcare? Okay. How about home automation? One. Okay, how many of you across believe your company has a focused strategy for IoT? Surprisingly low. So in a research that was conducted by a market research company, I think it was IDG, they talked to CIOs of various companies. 75% of CIOs have said that they're already exploring, and this is across businesses. 75% have said they're already exploring IoT in some shape or form. 95% know that IoT will have impacted their business over the next 3 years. So such is going to be the reach and extent of IoT. But let's now come back to this question, what is the potential of IoT? Is it simply a matter of tagging everything inside with a sensor? I mean, that's something you often hear. Right? Is it simply about just adding sensors everywhere? Honestly, if you ask me, the car on the right looks smarter to me, but in its simplest form, maybe it is that, and there will be some use cases which fall in that category. But this will be like one of those pre-1857 mutinies. It happened, yeah, there will be always a use case for that. they will eventually, but at Ericsson, what we believe is in order to have the 1857 scale mutinies and revolutions, the true value of IoT comes from building end-to-end ecosystems, which go beyond connections and data gathering. So Ericsson Industry Solutions is at the forefront when it comes to innovation and bringing some of these solutions to the market. And there are three primary industry verticals that we're currently focusing on: public safety, transportation, and utilities. Healthcare is also there within the public safety umbrella. One of the examples I would like to use to sort of drive home this, what does such an ecosystem look like to drive home that point? Let me use the example of a connected car. And this way I see some similarities with the panel discussion that we had yesterday. But it's also different at the same time. Yesterday's discussion was more around autonomous cars, but that's not what I'm talking about here. Autonomous cars brings its own set of conveniences and all that. That's not what I'm talking about, and challenges, of course. But imagine you are walking down the parking lot looking for a car, right? So your phone knows where you parked it. Your phone walks you to your car. As you enter a car, you unlock it using a built-in remote, which is in your phone. The car senses your presence, identifies you, changes the seating height, the steering height, the temperature, and everything based on knowing that it is you. Then you drive down the road. You interact with the car, voice activated. You download whatever software you want, right, with the App Store. The car is integrated with the city's traffic management system, alerting you about locations which might be congestion points, suggesting alternate routes, and enough jokes have been made about that yesterday, about Bangalore. Now, the city also connects to the car also connects to the city's parking system and tells you where you can find parking depending on your current location. We're talking about a smart city here. Then I pay for the parking, being fully aware, having the security and confidence that the backend that I'm using to make the payment is fully integrated in the city's parking system across all garages. I don't have to worry about fraud or any of that. The car performs periodic maintenance checks, and when servicing is due, it consults my PDA, my Outlook, or whatever the digital assistant that I'm using, and it suggests appointment slots, and also makes the appointment with the garage where my car needs to go. Software updates, again, nothing big, this is already happening. The car talks to the traffic lights wherever I am and suggests when to stop and go, depending on whether the traffic light is red or green. It's one way to follow the rules. And then if there's hazards developing along the road, the car talks to the road safety system and the weather systems to alert about whether there's sleet on the road, or there might be an accident or congestion points, and the alert shows up in a dash. Again, the obligatory joke about Bangalore traffic is that here it could be a permanent sticker that goes on your windshield. And all along, the car is monitoring your driving habits. Could I have the lights back on, please? The car is monitoring your driving habits, whether you're a good driver or a reckless driver and what have you, and reporting it to the insurance company, which automatically calculates your premium for the next year. So this solution is the most comprehensive connected car platform in the automotive industry today. And it's a great example, I think, of what it's like to bring ecosystem components together and generate a winning combination. Now, while that was just one example, our vision is that of a network society, which goes beyond 25 billion or 50 billion how many web connections. It's more about what people do with those connections to make their lives and their industries better and more efficient. And towards that vision, we have this Iot Accelerated Program that we had launched earlier. I'd be happy to talk to you separately about this. I think we've gotten some amount of interest in our booth about this as well. So it has three main components. One is the platform itself. We had a discussion about this yesterday. Think of this as PaaS for IoT. It's a way for developers to get a jump start without having to deal with the barriers, initial barriers of cost and complexity. Then there's the IoT Applications Marketplace, which is a way for all the applications that developers build to be hosted and to be monetized. It also has a development environment there. And then there's the Ericsson Professional Services. Here we bring our legacy of service, having been in the services industry for a long period of time, across industry verticals, guiding developers on all the way from initial stages of investigation and brainstorming, all the way to design, maintenance, and support. Along with that, we also have an ecosystem of partners. In academia, we do joint funded research. We have partnerships with Sony, for example, where we're testing wearables on LTE. With AT&T, we're bringing connected water to the city of Atlanta. With Verizon, we have a partnership where we're testing millions of devices per cell site as part of massive IoT initiative. The point is, it's not about one company. It's not about Ericsson or about any one company. The point really is how many companies really need to come together to build that ecosystem in order to leverage the full value of IoT. Now, it would not surprise me, in the coming years, companies in this room which are not currently talking to each other will need to find ways to engage with each other to build these ecosystems. Now that brings me to my final slide here today. We started today talking about this, an event of historical significance and it dating back to 1857. And as we continue along our path of innovation, we envision a world very different from the one we live in today. Enhancements in healthcare will mean that life expectancy for some will reach 150 years. It seems shocking right now. Real-time technologies and translation could mean that two people who don't understand each other's language at all can still converse with each other. Shrinking real estate, together with advancements in agriculture, smart agriculture, will mean food is grown in skyscrapers. And there will be people who will never know what it's like to have driven a car. So the thought I would like to leave you with is, as you look forward to 2030, what sort of a world do you imagine? Thank you.